A polynomial like a squared minus b squared is called the difference of two squares because, well, it's a difference, there's subtraction between the two terms, and both terms are perfect squares. A squared minus b squared can be factored into a product a plus b times a minus b. This factoring formula is pretty easy to use, so let's look at an example. 9x squared minus 16 is the difference of two squares, because 9x squared is a 3x that's been squared, and 16 is a 4 that's been squared. To factor the expression, we simply write the product of two binomials, 3x plus 4 times 3x minus 4. The factoring formula is pretty straightforward, but why does it work? Let's look at the same problem, 9x squared minus 16, and let's use an area model to justify the factoring formula. We can look at 9x squared as a square with an area of 9x squared. And we can look at 16 as a square with an area of 16. Rewriting the 9x squared and the 16 allows us to see the side lengths of the squares. The 9x squared is a square with side lengths of 3x, and the 16 is a square with side lengths of 4. Now we'll look at 9x squared minus 16 as a takeaway problem. We'll start with the large square, and then we'll take away the small square. That leaves us with a shape like this that has an area of 9x squared minus 16. To get from the area model to our factoring formula, we'll do a little rearranging of the area. Let's start by cutting it horizontally right here so that we have a large rectangle and a small rectangle. We can see that the shorter side of the small rectangle measures 4 units, and the longer side of the small rectangle must be 3x minus 4. It's the entire 3x of the large rectangle minus the 4 that we cut off. Now to find the area of the entire shape, we'll start with the large rectangle, and then we'll take the small rectangle and move it right here. The longer side of this rearranged rectangle measures 3x plus 4, and the shorter side measures 3x minus 4. We know that to find the area of a rectangle, we take its length times its width. So the area of this rectangle has to be 3x plus 4 times 3x minus 4. And there it is. There's the factored form of our polynomial, and we found it by using area models. It's interesting to see how we can find a factored form of this polynomial by using models, but let's face it, you're probably going to use this formula for difference of two squares if you want to factor things like 4y squared minus 9. We can see that's the difference of two squares because 4y squared is a 2y that's been squared, and 9 is a 3 that's been squared. So we can factor 4y squared minus 9 as 2y plus 3 times 2y minus 3. Let's try one more, and this one might be a little surprising to you. X to the 4th minus 16 is the difference of two squares. We'll need to think of the x to the 4th as an x squared that's been squared, and the 16 is a 4 that's been squared. So using our difference of two squares formula, we can factor that as x squared plus 4 times x squared minus 4. Now we can see some squares in those binomials, so let's see if we can factor either of them anymore. X squared plus 4 is a little bit tricky. That is two squares, but it's the sum of two squares, and the sum of two squares will not factor any further. But the x squared minus 4 is the difference of two squares, and it will factor into x plus 2 times x minus 2. So our final factored form of x to the 4th minus 16 is x squared plus 4 times x plus 2 times x minus 2.